Now, we have another thing over here, which is not part of the induction heating, and might show people what we do, or maybe we'll just leave this as a short, more the fact that it can be done. A lot of your European equipment, which are CNCs over here, are European based, runs the 380 volt. 380 or 400. They label it both ways these days. Used to always say 380, and then that's plus or minus 20%, which leaves you at the 400. I don't know why they've started calling it 400 now when it doesn't quite make 400, and anywhere in that range of 360-ish, 370 on up to 400 works. Anyway, a lot of times you'll get a transformer, and your transformer will change your voltage from whatever the input is to the output. This is not a 480 to 380 transformer. I had a couple little ones around. What this is originally, and I think, nope, we didn't take off the original plate. We were going to relabel it. I rewired it inside. So originally, this is a 480 with with adjustable taps, so you could adjust for your input voltage to change the output a little bit. And on the output side of it was supposed to be 208Y. Well, 208Y is actually 3 independent windings that are 117 volts each. As far as the nominal, 117 and a half is actually the nominal spec on that. But sometimes they call it 110, sometimes they call it 120. You hear it called all kinds of things. The nominal spec, if you look it up, is supposed to be 117 and a half is what they're shooting for these days. If the year was 1895 and you were Thomas Edison, it would have been 110. That was what we were shooting for. There's always some variance. Point being, instead of leaving those 3 coils connected in a Y configuration, maybe we'll draw this on the board sometime, but instead of, I guess we could, instead of being connected in a Y configuration, I broke loose the center tap that was grounded. And I viewed these as 3 independent buck boost transformers. Now, if you take 480 volts and you connect to each of those 3, to be bucking your 480 volts, you now have, we'll just make it simple and call it 100 for the second. Instead of having 480 volts, you have 380 if we take 100 off of each of those by setting them up to be bucking transformer coils. So that would put you right where you want to be on the 380. The truth is we're taking away a little more, but since we have the taps in here so that we can set this at you set it to a higher voltage input. And what that does is that would mean the connection that you'd hook it to if your voltage coming in was higher. So since your voltage is not higher, you hook it up to a higher one and it puts out less. So when it puts out less, it subtracts less off of the 480 volts. So anyway, that allows you to use a good sized transformer as a buck boost transformer. You can set up a whole nother main panel and get a whole lot more amperage available without spending a lot of money on a 480 to 380 volt transformer by taking a inexpensive surplus 480 to 208 transformer, and because it's only carrying part of the current, a 45, I think this was 45 kilowatt transformer, and that's now 45 kilowatts at the 100 volts that you're using it to buck instead of 45 kilowatts spread over the 380. So it doesn't take as big of a transformer to carry a whole lot more current into your shop, and then that way we wired this whole sub panel that is 380 volt. So I don't know how unconfusing, or we'll make a little bit of a sketch, I guess, up here on the board. Those are nice squiggles. Believe me, they are. Yes. Okay. So from here to here, you have 117 and a half nominally. And from here to here, you have 208. That's your normal voltage. So by disconnecting this one here, you cut that loose, you now have 3 independent coils that are 117 and a half each. And you can use those as bucking coils or boosting coils onto your 480 that's nominally coming into your shop. And if you don't understand that, I'm not going to go into the whole explanation of bucking and boosting. Talk to one of your electrician friends. And they may be asking, well, which wire goes on? Just try it. If this one hooked onto your power gives you more voltage, then that's the wrong way. Then hook this one on, and that one is the one you'd use for less voltage. I forget how I hooked that up. That was one of the things, if we did a panel on that one, I'd pull the panel off, but I figured out originally for whether I wanted the buck, which terminals to make it buck and which to make it boost. I did it by trial and error, the good old-fashioned way.